Here it is, January 2022, middle of the winter, very cold. It was down to 12 below zero Fahrenheit last night, and so things are very frozen here. The row of things you see behind me, those are navigational buoys that guide ships in and out of the Great Lakes to the various ports, and they are brought out of the water here because it's so cold in this northerly environment that the ships are unable to navigate due to the ice cover and all of that. So we come up and we look at these buoys and collect various things from them, but especially we collect these filtering bivalve mollusks, zebra mussels and quagga mussels, which are invaders that came here from Europe many years ago. But we collect those for a lot of reasons. Number one, to learn more about the health of the river itself, but also because, as many of you know who follow me, we study a lot of pathogenic organisms, things that cause diarrhea, waterborne diseases, and so forth. And it doesn't matter whether it's winter or summer, they can move up and down waterways. And in fact, large navigable rivers like the St. Lawrence are major corridors through which waterborne disease pathogens can move between the various cities and into the countryside and so forth, or where diseases that start out in animals, livestock in agricultural areas flow into the water and then move down and can contaminate areas of human habitation. And of course, because of the nature of rivers as a major transit for movement of people and goods, major rivers have been the site of the development of most of our major cities in the world, whether it's Montreal or Chicago here in North America, or Budapest and Vienna over in Europe, or places in Asia as well. So we have developed a method of using these navigational buoys as a substrate for collecting filter feeding organisms like the mollusks, but it could also be filter feeding insects like caddisflies. We collect them, we take them to the lab, we grind them up, and we look for the presence of these pathogens. And by doing that, we can get an idea of the distribution and the abundance of these pathogens that can make people sick and can cause major outbreaks. For example, here on the Great Lakes, in Milwaukee, 1993 was the largest outbreak of cryptosporidiosis on record. There were about 100 deaths, but there were over 400,000 cases of people getting diarrhea from this pathogen, and it occurs all over the world. And in fact, we now know, after many years of studying it, that it is one of the top 3 killers of children as far as diarrheal killers go. So it's a deadly pathogen. We have had and continue to have major outbreaks of this. And one way that we're trying to learn to monitor the existence of these pathogens, the movement of these pathogens, and therefore predict when and where outbreaks might occur and protect ourselves from it, we can do that by using these particular methods. And so we're very proud that in our lab, as well as with collaborations at other universities, especially Johns Hopkins University over the years, we've been able to develop a system now of using these sentinel organisms attached to navigational buoys as a very powerful way of monitoring for the diseases. And so all over the world, people have been picking up on this strategy and copying it so that we're getting a better global network. So I'm going to get to work now, collect some specimens, take them to the lab, and down the road, we'll let you know what we found. Take care.